All right, so hi everyone, and welcome to this new video. We're trying to record from the nature because it's always good to have some, you know, nice air that can inspire. As then today we're going to talk about VLANs, virtual lands. So, what are the VLANs? What are they useful for? Right? Before we talk about the VLANs, briefly, let us see what the LAN is. The local area network, you know, where we have many users with a computer. We want to share some resources, or we want the computer to talk to each other. We build a network. Then we're going to use a switch and we connect these devices, these computers, to the switch, and therefore they can talk to each other. That's a local area network. But what we're going to see this time is that we can virtualize that concept. Instead of having a switch that does this job, we can have some kind of virtual switches inside the switch. You remember how we do the virtual machines inside the server? It's the exact thing that we're going to see today. And for that purpose, we're going to just analyze a couple of points here that can help us to understand what a VLAN is. So, what's a VLAN? Let's see what it is. Why a VLAN? Because we have to see the reason why we should use VLAN and the advantages of VLANs. Because if we use a VLAN, that means it presents some advantages, and we're going to explore some of these advantages. And some concepts that are linked to the VLAN are VLAN tag and VLAN ID. We're going to talk about them, as well as the switch port modes. Because you remember I said a little earlier that computers need to be connected to a switch, and the switch has multiple ports, right? So we have to set these ports, these interfaces of a switch, to apply the concept of VLANs. And this configuration is what we call switch port mode. And then we're going to talk about another concept which is linked to the VLAN. We call it SVI, or switch virtual interface, right? We're going to see why it is important to consider the SVI. And very briefly, we will talk about the private VLAN. We will have a video to talk about the concept of private VLAN because it is important to explain what it is. So let us jump ahead and talk about those things. So, what is a VLAN? To explain this, we have to know that a VLAN is, an acrostic of virtual local area network. And I define it as a customized logical network that is created from one or more physical locations to group users by function, by domain, by department, or any other criteria that we can select. So, let's say we have a lot of users in a company, right? We want to group them the way the organization, the company is organized. So VLANs are going to help us achieve this goal. Look at this, for example. We have users in the sales department, users in the finance department, some in the IT, and some users in the HR. There are some documents that must be internal to the HR. And of course, salespeople should not have access to technical documents that are managed by the IT team. So we want to group these users by department so that they can share their resources there without the fear of having these going everywhere. And we're going to use one switch because you see this one we have on the screen there has 24 ports. If we have 3 salespeople, 4 users in the finance department, 4 in the HR, and 3 in the IT department, we are going to connect them to the same switch, but we have to keep them separate. This is going to be like virtual switches inside the physical switch, right? Another way we can explain the importance of, the concept of a VLAN is that we can have these users in a building, the first floor, second floor, and third floor, right? So if we have a salesperson at the third floor, another one on the second floor, and a third one in the first floor, for instance, we are going to create their own network, but it's not going to be physical. It will be logical. That is a network that goes across the floors. So as you can see, this is going to be virtual. That's what we call it, virtual local area network. You remember in the beginning I said a local area network is a way to group users so that they can exchange resources or they can communicate. When we make it virtual, then we put the V, which is VLAN. Now, the question we can ask is why a VLAN? And there is a little bit of history here. You can pause this video to read the story behind the VLAN, right? But briefly, we have to know that the concept of VLAN was created in the 80s by Walter David Sinkowski, right? Walter David Sinkowski, he was working at Bell Labs Computer Engineers, and he had a problem of broadcast. Let me hold 1 second here. By the way, if you don't know, this is the picture of Walter, Dave. But I spoke about broadcast. I want to provide some analogies to explain this concept. Imagine you are at a show, let's say an election of Miss World. The presenter who is in front of you on stage will be talking to everybody, and everybody is going to listen to what the presenter is saying. That's a broadcast, an entity talking to everyone. And when they announce the person who wins the election, the presenter is going to say it out loud. The winner of this year of Miss World is, everybody's going to listen. Then the presenter will give one name. Everybody in the audience is going to hear this name, but only one person will stand up to go and receive the prize. That's how broadcast works. A computer is going to send a packet to all the computers in the network, but only one will process the information. But as you can see, it can be a lot of noise. If we have everyone in the audience talking to everybody, it's going to be a little chaotic. So the VLAN here will reduce the size of the end users that will listen to this information so that a potential user can process it. So I wanted to present this analogy so we can understand what a broadcast is. And going from this, we're going to see that we can separate the broadcast zones inside the same environment. Going with the same analogy, imagine we have a building with 3 floors. We can have a ceremony going on the first floor, another one on the second floor, and the third one on the first floor. These are different audiences, and the broadcasts, of course, are going to be limited by the floor. But all these audiences be in the same building. So you can see we have different broadcast domain inside the same building. That's why we can also have several VLANs in the same switch. Now, this being said, we continue to explain that this separation helps for functional reasons or for security reasons. If I take the three audiences in the building, we have the Nobel Prize that has to be given on the first floor, Miss World on the second floor, and the third ceremony on the third floor. We keep these informations separate from one domain to the other. So functionally, it works. And security purposes, management reasons, and even scalability, because we can use one switch and divide it into multiple broadcast domains. Maintenance reasons, traffic reasons. So we have many reasons why we need a VLAN. Now, let us look at this picture. As you can see, we have servers that communicate with the end users, endpoints. When they are directly connected, we can have a lot of broadcasts, which can create a lot of noise, but also some security purposes where every end users here can directly go to any of these servers. It will be very difficult to regulate. That's why it's wrong. Not the best way to do. Now, the VLANs provide then some advantages from what we just said earlier. Imagine we have these four departments: the sales, the HR, the finance, and the IT. We want these users to be grouped. How many switches, physical switches, are we using here? 4 switches. The problem is that we are wasting ports because the sales department has only 3 users and they're using a 24-port switch. The IT team, 3 users, 24 switch ports. So we're using 4 switches, which is a waste. But you can see we can group them into one switch and just share the ports. Assign the ports to a department and make sure that we don't have traffic going from one domain to the other. That's why we're going to have the reduction of the capital expenditure. Because we're going to buy less switches, instead of 4, we buy only 1. The operation expenditure as well, instead of maintaining 4 switches, we're just going to maintain 1. But this also improves resilience and scalability, security, and it is even easy to manage. And also among the advantages of the VLANs, we have the separation of domains by removing the boundaries of location. So we can create a network that goes across physical location. And this is going to reflect the functional organization of our company. That's how the IT department is going to have a network and they're going to manage their stuffs over there. The servers are going to have their own network. They manage their security. The finance department is going to have their network. They manage their resources. But we use less devices for this to happen. We can have a finance member, as you see, on the 3rd floor, 2 finance users on the 2nd floor, 1 finance user on the 1st floor. And they're going to use the same network because we implement the virtual local area network. And this goes with the tags and the VLAN ID. Let us talk about this. Because in order to identify a VLAN, we need some kind of value, right? That's where the VLAN ID comes to play. And it is part of a field in a frame, which is called a tag. Inside the tag, we have some values that we are not going to emphasize more on, like the protocol, the priority. We don't care about them for now. But we are more attracted by the 12 bits that identifies the VLAN. So it's a number that is given so that we can differentiate. Let's say, for instance, we have the IT department, which has their own network. We're going to give it like number 10. The VLAN that groups the IT, the finance department, we're going to give it, for instance, number 25, and so on and so forth. And that's how the switch is going to know how to assign some specific ports to a department because we give that department a number, an ID. So as you can see, the VLAN ID identifies a VLAN across the trunk port. Now, a trunk port is also kind of port that is used to carry multiple VLANs packets. It's like a highway. We send so many kinds of traffics there. But for these packets to be identified by the two endpoints, the packet needs to be belonging to a VLAN. That's why it will carry the identification of the VLAN that it belongs to, so that when it reaches the destination, only the ports that are listening to that VLAN are going to be interested. You remember the example of the three ceremonies on a building? That's what we're talking about here. And the VLAN IDs we have of several types. For instance, first of all, we have to know that the number goes from 0 to 4095. And 0 and 4095 are reserved for the system only. You will never see these VLANs when you check the configuration of a switch. You cannot use them. That's why you cannot see them. Then you have VLAN 1, which is a normal VLAN ID, and it is the Cisco default. So all the switches come with VLAN 1. That can be used. All the ports by default belong to that VLAN. Then we have VLAN 2 to 10.0.1. These are normal VLAN IDs that you can create, use, you can modify, and delete. But of course, you cannot delete VLAN 1 because it has to be there. VLAN 1002 to 1005 are normal VLANs as well, normal VLAN IDs. But these are used by Cisco for FDDI and token ring, so you cannot delete them. This means we have 5 VLANs by default that come with a Cisco device. VLAN 1, where all the ports are by default assigned. Then VLAN 10.02, 10.03, 10.04, and 10.05 that are used for FDDI and token ring. Then you have all the remaining ports from 10.06 to 40.94, which are called extended VLAN IDs. They can be created, so you can create a VLAN and give it one of these numbers. And you can modify, you can delete them even if you want, because these VLANs are used for Ethernet only. And we spoke about the switch port mode because you remember when we spoke about the trunk? I said an interface of a switch has to be configured. So we have to tell the switch what to do with the ports that it has. Among the 24 ports, which VLAN a port has to belong to. In other words, which VLAN's packet has to go through which port. Those are ports that are assigned to a VLAN. So we have different modes of configuring. We have the access mode, which consists of assigning an interface of a switch to a specific VLAN. You remember, if we have the sales department, we want to give them 3 ports so that their computers can communicate. That will make their network. We can then tell the switch that create VLAN 22, for example, call it sales, and assign port 1, 2, and 3. Those 3 interfaces, make them member of that VLAN 22. Therefore, any packet that has a VLAN ID 22 will go to only those 3 ports. The 21 others are not going to receive these packets. I hope you're following me that far. Then we have the voice access mode. This is for the interfaces where we want to connect an IP phone, because the IP phone, they use voice. Computers use data. So you know, voice over IP is a specific configuration we give to an interface so that it can carry voice over IP. It can carry voice packets. Then we have the no-negotiate mode. This is a way to ask the switch to turn off the dynamic trunking protocol on an interface so that that interface will remain trunking. We spoke earlier about what a trunk is. So we can tell the switch, just keep this port to carry multiple VLANs packets. The dynamic auto mode is assigned to a port that can be trunking. If the other end is willing to. For instance, it's a way to say, if somebody wants me to be a trunk, I will be a trunk. Otherwise, I am an access port, right? Then we have the dynamic desirable mode. This is a port that would like to be a trunk port if the other end is okay with that. I'm trying to take some analogies. So it's a way to say, I would like to be trunking. Is there any port on the other side that is okay with that? So if the other end is, let's say, dynamic auto mode or desirable mode, then I'll be a trunk. But the difference with the auto mode is that the interface will say, if somebody wants to be a trunk, I am there. That if there is nobody, that's fine. And of course, we have the trunk mode. That's where we tell the switch, make this port a trunk. Make this port a trunk, so that that port can carry multiple VLANs. Right? As you can see, we have different VLANs that we have created, but these are purely layer 2 stuff. What will happen if the sales department would like to send some traffic to the IT department? That's where we go to layer 3, where we manage IP addresses. VLANs are now going to need a kind of a gateway or a door through which the communication with the VLANs can occur. That's when we use the switch virtual interfaces, or SVI. Let us see how it works. Before there, we have to explain that a switch virtual interface is a routed virtual interface in an iOS that represents the layer 3 access for the devices, which, in other words, it's a gateway. It's the layer 3 representation of the VLAN, a door to access the VLAN. Let's see. Let's just assume that we have these 4 VLANs in our environment. And we would like to do routing, that is, users in VLAN 10 would like to send packets to users in VLAN 509. Of course, it's not doable because VLANs are kind of separated from each other. We grouped users so that only users within a VLAN can communicate. But if we want to do this, going from one VLAN to another, we're going to need a door. That's what we're going to assign a virtual interface to each of these VLANs. With these virtual interfaces, we can route the traffic across. And VLAN 3007 can communicate with VLAN 22. We would like to talk a little bit about the VLAN trunking protocol, because when we have multiple switches, let's say, that manage traffic in a building of several floors, we would like to have the possibility to create VLANs at once instead of creating them in other switches. This can, bring some errors. Therefore, we're going to create a community that is going to group switches that manage the same VLANs. Of course, this is going to require a bus, a place where we create VLANs. We can then create them, modify or delete in the server, that is the server of the community. And these VLANs will replicate automatically to the clients. But we also have the transparent switches, which are just going to pass the information to the clients across without taking care of them. That is, for example, it's just going to be like a carrier. A client is connected to me and a server, but I'm transparent. We create the VLANs on the server, I pass them to the client, but I am not concerned with those. And for this community to work, a couple of things have to be considered. They must have the same domain and they must share the same password. When we do the demo, we will see what we're talking about. Now, we said we're going to briefly talk about the private VLAN. So the private VLAN permits to isolate completely a group of devices by restricting access to them from other VLANs. So we're not going to route. They're just going to be by themselves. We will have a video that explains this. But for the moment, let's say we have 3 VLANs, and on top there we have a private VLAN. So the concept is to break the switch like this so that the private VLAN is going to be on its own. So these are stuff that I think are important to understand about VLANs. And it will be time for demos. So follow me on the next video as we will be doing some demonstration. Until then, take care.